Before, uh, next question is given that a railroad car of mass 2 into 10 raised per kg and moving with initial speed of 5 meter per second collides and couples with three other occupied railroad cars, each of the same mass as a single car and moving in the same direction with the speed of meter per second. What is the speed of the four cars after collision? How much energy is lost in the collision? So let's say this is the first railroad car and this is initially moving with a speed of 5 meter per second. So its initial speed is 5 meter per second and its mass is 2 into 10 raised power 4 kg. Let be m1. So let m1 be its mass and now it couples with three other railroad cars after collision. Okay, so these are three other railroad cars and moving in the same direction, but with a speed of 2 meter per second. So let their speed be u2 be 2 meter per second. They collide, and now these are four cars coupled together. These are four cars coupled together, and let their final velocity be we have to find their final velocity and the mass remains the same. So according to law of conservation of momentum, let's use a law of conservation of momentum. So according to so for each of these cars mass is 2 into 10 raised per 4 meter per second. So these are three cars, so here the total mass is before the collision of three cars would be 6 into 10 raised per 4 kg multiplied with 3, and after collision their mass would be 4 into 10 raised power 4 kg. So let this be their final mass m, which is equal to 4, and m2 be the initial mass of the three cars. So according to law of conservation of momentum, initial momentum of the system is equal to the final momentum that should give us the velocity of the coupled four cars. So according to law of conservation of momentum, so according to law of conservation of momentum, initial momentum of the system, that is m1 u1 plus m2 u2 should equal to the combined mass, that is m into combined velocity. Now m1 is 2 into 10 raised power 4 kg, u1 is 5, m2 is 6 into 10 raised power 4 kg, u2 is 2, m is, these are four cars, so this is actually 8. So 4 into 2 is 8, so this is 8, and this is 8 into 10 raised power 4 kg into V. We have to find V, so 2 into 5 is 10, so this is 10 into 10 raised power 4 kg plus 6 into 2 is 12 into 10 raised power 4. This is 8 into 10 raised power 4 into V. So here 10 raised power 4 is common, and 10 plus, we are left with 10 plus 12 is equal to 8 into 10 raised power 4 into V. This gets cancelled, so V is equal to 22 by 8, which is equal to 11 by 4, and that should be equal to 2.75 meter per second. So the final velocity speed of the four car after the collision is 2.75 meter per second. And now we have to find the energy lost in the collision. So energy lost is in the collision. So energy is lost. That means that the initial kinetic energy of the system is greater than the final kinetic energy of the system. So we just have to subtract that. So now we are going to find out the energy, that is the kinetic energy lost in collision. And that is the initial kinetic energy of the system minus the final kinetic energy of the system. Now, the initial kinetic energy of the system is the kinetic energy of the first railroad car, that is half into 2 into 10 raised power 4 into its speed, which was 5 meter per second, plus. So this is 5 square, v square, so half into, now the kinetic energy of the three railroad cars, that is half into mass is 6 into 10 raised power 4 into their initial speed was 2. So this is 2 square minus half into mass of the full railroad cars, which is 8 into 10 raised power 4, and their velocity, which is, let me just take it as 11 by 4. So this is 11 by 4 the whole square. Okay, let's try to simplify this. So this is equal to 25 into 10 raised power 4. This is 2 3 that is 6, 2 square is 4, 4 3 that is 12. So 12 into 10 raised power 4 minus this is 4, and 4 into 10 raised power 4 into 11 into 11 upon 4 into 4. So this gets cancelled, and finally we have 12 plus 25 is 37 into 10 raised power 4 minus this is 121 divided by 4 into 10 raised power 4. 4 3s are is 12, and 121 divided by 4 gives me, this is 30.25. So this is now equal to 37 into 10 raised power 4 minus 30.25. Okay, so this is 30.25 into 10 raised power 4, and now 10 raised power 4 is common, which gives me 37 minus 30.25 into 10 raised power 4, which is equal to 6.75 into 10 raised power 4 joule. So this much of kinetic energy is lost in the collision. Thank you for watching.